Okay, we're going to go ahead and get started now. Next up is a short presentation from Woo-Sung Yang about the NERSC resources. Are you ready at NERSC?
Yes, I am. Very
well, take it away. Thank you.
All right, thanks. Hello, this is Woo-Sung Yang, and I'm a NERSC user engagement group. I'm basically a consultant here, and I'm going to talk very briefly about the NERSC resources here. So NERSC, which is for National Energy Research Scientific Computing Center, was established in 1974 at the Lawrence Livermore National Laboratory to basically support the fusion energy science. But it was relocated at the current location here, Lawrence Berkeley National Laboratory in mid-90s. And then the mission has been broadened here. So now it supports the DOE Office of Science mission, which is basically to accelerate scientific discovery at the DOE Office of Science through high-performance computing and extreme data analysis. NERSC is a national user facility, and we have about 7,000 registered users for 800 projects. And each day, hundreds of users are logging into a NERSC system, running, say, up to 600 codes here. So NERSC computation allocation is primarily controlled by Department of Energy. Actually, 80% is awarded to the PIs as the DOE production allocations through the application process called RCAP. So this is strictly the proposal-based, and the Department of Energy program managers basically select which projects to be awarded, and depending on the proposal, the computation time between tens of thousands hours to tens of million hours awarded. And then 10% of NERSC allocation hours are given to the ALCC program, the projects. The ALCC meaning the Oscar Leading Computing Challenge, and the rest, 10%, is saved as a NERSC reserve. So this chart shows that the allocations are given to the various diverse the science fields. Oscar, the biological energy research like climate and biosciences, and basic energy science like chemistry and geoscience, material science, and user facility, and the fusion energy science, and high energy physics and nuclear physics. And a very small portion is given to the small business here. So our focus is basically to improve the science through the computing. So in alignment with the NERSC users, and as a result, we think that NERSC users produce the more than any centers. I mean, the NERSC users produce the paper publications more than any centers in the world. We estimate that that is about 2,500 per year, including many prestigious journals like Nature and Science. And we believe that we have 6 Nobel Prize winning users as well. So NERSC basically have the supercomputing procurement every three to 4 years. And the last system, NERSC 7, which is called Edison, was introduced in 2013. And now we have a Corey system, which was introduced in 2016. Cori has both house-wide nodes and the nice landing nodes here. So because of some drastic change from the Edison to Cori, we launched the NESA program so that to prepare the NERSC users to prepare for this hybrid architecture. So NERSC 9, which will be introduced in 2020, next year, late next year, it'll be having the CPU and the GPU nodes here. So once again, the change will be very drastic. So NERSC is trying to help users to prepare for this hybrid system, heterogeneous system here. So NERSC 9, as I said, is the next system, and it is named after Saul Perlmutter, who is the lab scientist. He is the winner of the 2011 Nobel Prize in Physics for discovery of accelerating expansion of the universe. And this system will be a Cray-Shasta system, and we expect that its performance will be 3 or 4 times more than the Cori system here. So this will be our first NERSC system designated to both the scale simulation, larger scale simulation, and data analysis from the experimental facilities. So some key features here is that it will have both NVIDIA GPU nodes as well as AMD CPU nodes. And it will creates a new slingshot interconnect network. And it'll have the optimized data software stack so that we can do more data analysis and the machine learning type of things at scale more efficiently. And the scratch file system, currently we use the Luster, but it'll be all the flash file system for this NERSC. So as I said, that because this is a kind of drastic change from the Cori system, NERSC launched the app readiness program quite recently to prepare the users for this new heterogeneous system here. So we expect that the NERSC 9 will be delivered in late 2020, next year. So that's all I have to say.
Okay, thank you very much. Appreciate that.